Hey everyone, Mac here, and we are doing systems of equation. This is version C. Now, in this one, it's really important that you've done A and B as well, okay? Because C is definitely going to be harder than the first two, and you've got to do all of this to know how every situation could work. So, if you haven't seen that video yet, or the video where I made the original and the equations for version A and version B, I strongly suggest you go to maxtutorials.com, and you can see it right down here on the bottom. I wrote it out there for you. And just as a reminder, what we're looking for is something like negative 2x and a plus 2x, or 3y and then minus 3y. We're finding a way to get rid of a letter. So we're trying to find how do we change a problem to make that work? And we found different ways that we can alter problems to make it work. But if you look at number one, the threes and the fours don't line up and the twos and the fives don't line up. So that's not very pretty. So I'm going to have to do something now to both of the equations. And so now we're looking at the least common multiple. What's the smallest number that I can make 3 and 4? What's the smallest number that 3 and 4 will both go into? And the answer is 12. If I look at 5 and 2, well, the answer there is 10. Okay, so it doesn't really matter which one. They're all going to work equally. The actual number here kind of messes things up. So I'm going to kind of cover there. I have to multiply now both equations. Now, I have options. If I multiply the numbers by themselves, that's always going to work, okay? And so I can multiply the top by negative 4 and a positive 3. That'll give me negative 12 and 12. Now, I could also go negative 3 and positive 4. It really doesn't matter, okay? I just need one of them to be negative. And my other option would be, now the signs already match up the way I want with a plus and a minus. So I can just do the top by 5 and the bottom by 2. Okay, and if you notice, I'm going to get a positive 10 and a negative 10. Let's do that. Okay, and it doesn't matter. I could have gone either, but just make sure you multiply all three. 15x plus 10y equals 55. And on the bottom, I'm going to get 8x minus 10y equals 14. Now I'm going to add them up together. And if you notice, the 10s go away. And I'm left with a 23x equals, what is that? 69. And if I divide each by 23, you can use your calculator if you want to, but hopefully you can see that that's just going to be 3. Okay? And then all I have to do is plug in the x to any of these problems. It doesn't matter which one. I'm going to plug it right into that one. Well, 3 times x is 3 times 3, which is 9, plus 2y equals 11. Now I'm going to subtract 9 from both sides. 2y equals 2, divide each side by 2, y equals 1. So my answer is going to be 3, comma, 1. All right, let's go on to number 2. All right, now number 2 sets up a little easier. I could do the top by a 2 and the bottom by a 3 and make one of them negative. But I look at the bottom and I just realize, oh, wait, all I have to do is multiply the bottom by 2. If I multiply the bottom by 2, that's going to give me a negative 4y on the bottom, which matches with my positive 4y on top. But I got to do all three. I'm going to get a 4x minus 4y equals 4. Let me zoom in a little bit, make this nice and big for you. Okay, and so I'm going to just copy the top because I like to see them on top of each other. It makes it a little bit easier to do it. Okay, and then I can cross these out, and I'm left with 7x equals 14. And I know you can do the rest in your head, but just write it out. Why not? X equals 2. Now I can plug this into any of them. I'm going to go right there. 3 times x, that's 3 times 2. What's 3 times 2? 6. Plus 4y equals 10. Once I subtract 6 from both sides, I'm going to get 4y equals 4. Divide each side by 4, y equals 1. And that leaves me with 2, comma, 1. All right? Number 3. Okay, well, I can't make a 2 say 5. I can't make a 5 say 2. I can't make a 2 say 3. And I can't make a 3 say 2. So this is the situation where you have to multiply both the top and the bottom. What are we going to do it by? I'm going to do the top by 3 and the bottom by 2 because that'll give me a plus 6 and a minus 6. I could go 2 on top, 5 on the bottom, make one of them negative, but these are nice small numbers, so let's do that. That's going to give me a 15x plus 6y equals 66. And on the bottom, that's going to give me a 4x minus 6y equals 10. And when I put it all together, I'm going to get 19x equals 76. Oh dear, does that work out? And my brain is thinking right now, Let's see, 19 in there. Would a 4 work? A 4 would work. My x is going to equal 4. You could use a calculator if you need to. Not many people know their 19 times tables. And that's how you would have to do it. Okay. And so now I'm going to take that x and I'm going to plug it in right there. Okay. 2 times x is 2 times 4, which is 8, minus 3y equals 5. I'm going to subtract 8 from both sides. Boom, die. Negative 3y equals, add a line, change the sign, negative 3. Once I divide each side by negative 3, I get y equals positive 1. Okay, so my answer, if I write it like an ordered pair, you write your x first and you write your y second. Remember, it looks like that. And that's how it will likely end up on your answer key. Okay. All right. Going on to number 4. Well, can I make a 4 say 3? No. Can I make a 3 say 4? No. Can I make a 5 say 1? No. Can I make a 1 say 5? Yeah, I can. This one is just going to pop out as I'm going to multiply by 5. And I'm going to get a positive 5y and a negative 5y. Watch. Boom. 15x. Boom. Negative 5y. Boom. Equals 50. And on top, I'm going to get a 4x plus 5y equals 7. Boom, die. I'm left with 19x. Ooh, that 19 again equals 57. Can 19 go in the 57 equally? Well, let's see. 19 times 3, that would be 3. Yep, it works. And you could use your calculator likely if you need to, if your teacher lets you. I'm going to plug it right here in the bottom. Boom, boom, boom. 3 times x, or 3 times 3, because x is 3, will give me my 9, minus my y equals 10. I'm going to subtract 9 from both sides. Look at me show all my work. Wow, I'm proud of myself. Equals 1. And if I divide each by a negative 1, just my y equals negative 1. All right, show your work. Why not? That helps eliminate mistakes. All right, number 5. I can't make a 2 say 3 or a 3 say 2 or a 3 say 2 or a 2 say 3. So now I got to multiply both sides. What am I going to do it by? It doesn't really matter. I'm going to do the top. I'm going to do my parenthesis there. I'm going to do the top by 2 and the bottom by 3. The reason why I do that is because I see that the signs right here are already mismatched, which is what I'm looking for. So let me just go with there. It just takes away another negative I've got to worry about and make a mistake on. So I'm just going to do that. And once I get that, I get a 4x plus a 6y is going to equal 22. And if I do the same thing on the bottom, I'm going to get a 6x. Oh, not a 6x, sorry. That's going to be a 9x. Okay, minus a 6y is going to equal 30. Look at that. Those sixes are gone. And I'm left with a 13x equals a 52. Wow, these are some nasty numbers I'm getting to divide with because 13 is prime too. I can't even break that down. Will 13 go into 52? It will. It'll go in 4 times. Okay, use your calculator if you don't believe me. All right, I'm going to plug my x. Let's go. We haven't done the top in a while. Let me plug it in right there into that x. So it's going to be 2 times x, or 2 times 4, which is 8, plus 3y equals 11. Now I'm going to subtract 8 from both sides. Boom, boom, die. 3y equals 3. And once I divide them both by 3, I get a y equals 1. So what's my equation? When I take a look at that, I write it as an x, comma, y. Whoa, why did I do that? X, comma, y. All right? All right, let's do the other column. You guys are doing great, hanging in there. All right? I can't make a 2 say 3. I can't make a 3 say 2. I can't make a 4 say 2. But look, I can make a 2 say 4. How do I make 2 say 4? I times it by 2. But remember, I got to do the whole equation. I can't just do the 2. Now, will that make my signs line up? Yep, because I want 1 plus and 1 minus. 2 is the answer. So what is 2 times 3x? 6x. What is 2 times the negative 2y? Negative 4y. And what is 2 times the negative 8? That would be a negative 16. Now the top, I'm just going to copy. Boom. Now I'm just going to add down. They die. I'm left with 8x equals negative 16. Once I divide each side by 8, I'm left with x equals negative 2. Okay, some sloppy writing in there. I apologize. I'll do better on the next one. So once I plug my x in there, I'm going to get 2 times the negative 2, which is a negative 4 plus 4y equals 0. Now I'm going to add 4 to both sides, which gives me 4y equals 4. And once I divide everybody by 4, my y is going to equal 1. So I get negative 2, comma, 1. Going on to number 7. All right, now here I can just choose. What can I do? Sorry about that. What can I do with number 7? Well, I can multiply the bottom by a negative 5, and that'll kill my x's. But I can also multiply by a 2, and that'll get rid of my y's. Well, as I said before, if you can never use smaller numbers, use them. It'll make your life a little bit easier. Oh, my dear, what am I hitting here? Going back to C is where I want. Okay, I apologize. Here we go. So now I'm going to go 2 times x, which is 2x. Let me write it over here a little bit. 2x. 2 times negative y is a negative 2y equals, and what is 2 times 0? It's just a 0, okay? Now I'm just going to copy the top. And once I do that, they die, and I'm left with 7x equals 14. Divide each side by 7, and I get x equals 2. Now it's just a matter of plugging in. If I plug in right there, and I can plug in on top, it doesn't matter. But I'm just going to get a 2 minus y equals 0. Once I minus 2 from both sides, I'm going to get a negative y equals negative 2, which gives me a positive y equals a positive 2. And my answer is 2, 2. There's my x, there's my y. All right? Few more. I can't make 2 say 5. I can't make 5 say 2. I can't make 3 say 2. I can't make 2 say 3. So this one, I have to multiply both. I have no choice. Now, what's the smallest numbers I can make it? I can kill the x's. You know what? I haven't killed x's in a while. It's going to give me some big numbers. I'm just going to go 2 and 3, okay? Because I noticed that that's going to give me a plus and a minus 6 if I do that. So right here, I'm going to get a 4x. Right here, I'm going to get a plus 6y. And right here, I'm going to get a 36. Right here, I'm going to get a 15x. Right here, I'm going to get a minus 6y. And right there, I'm going to get a 21. Boom, die. And that gives me a 19x. Oh, that dreaded 19 equals a 57. And once I divide each of these by a 19, x is going to equal 3. Now, the way I did in my head, as I just thought, what number times 9 will give me a 7? And then I just got to say, well, only 3 times 9 is going to give me that 7. So that'd be a 27. I bring a 2 plus 3. That gives me a 5. And that's just kind of what I'm doing in my head. But if you needed to use a calculator, I bet you your teacher let you. All right, so let me plug it in there. Okay. 2 times x, or 2 times 3, is 6, plus 3y equals 18. Once I subtract my 6 from both sides, I'm left with a 3y equals 12. Divide each side by 3. Boom, die. Y equals 4. Look how quick that is. It didn't really take me any extra time. In fact, it probably would take me longer to do it in my head because I'd be going, By writing it out, it took a little extra writing, but I got there. All right, if you notice, I can't make 3 say 2, or 2 say 3, or 3 say 4, or 4 say 3. I'm going to do the x's this time because I do like to use with smaller numbers whenever I can. And so I'm going to multiply the top by 2 and the bottom by 3. And that'll give me 6 and 6. But there's a problem. You see the problem? One of them has to be negative. Does it matter? No. I just see, though, that the bottom has negatives in it. If I multiply by a negative, they'll become positive, which maybe would help me later on. I don't know. But let's just go ahead. That's going to give me a 6x. That's going to give me a plus 6y. And that's going to give me equals a 42. And on bottom, that's going to give me a negative 6x. That's what I wanted. That's going to give me a plus 12y. And that's going to give me a positive 30. Ooh, these are going to be nice big numbers. Okay, that's going to give me an 18y equals 72. Divide each side by 18. Same thing. What times 8 would give me a 2 at the end? And my brain goes 4, because 4 would be 32. Well, would the 4 and the 3 give me a 7? Yeah, it would. That's going to be a 4 for my y. Make sure you know it's your y, because sometimes where I see students make mistakes is you don't keep the x or y going down. You go, oh, the answer's 4. Well, what's 4? It's just 4. But you got to tell me what letter, because then you got to go back in and plug in there. Okay, and you don't want to plug in the wrong spot. All right. So here I'm going to get 3x plus, it's going to be 3 times 4. Well, what's 3 times 4? 12. equals 21. Letters on one side, numbers on the other. So I'm going to rearrange the furniture a little bit, and then I'm going to divide by the 3, and I'm going to get my x equals 3. There's my answer. My answer is 3, comma 4. All right, x and y. And lastly, I look at this, and can I make a 2 say 6? Yep, I can. And I'm going to multiply it by 3, not a negative 3, but just by a 3, because I'm going to get a negative 6, which is what I want. Okay, and here I'm going to get a minus 6y equals 3 times 0 is 0. I'm just going to copy the top. Take the extra second to do it. You're going to like it so much better to just see that and then go negative 3y equals 6. And now it's super easy to solve. Where you start going corners, I'm going to subtract that, this from that, and you're looking in the corner. I don't know, man. It's just a little bit harder. Let's just make it nice and easy. Do a little extra writing. Now I'm going to plug this in. I'm just going to plug it into this one. It's a y equals, right? Boom, boom. 6x. Now, what's a positive 3 times a negative 2? That's a negative 6 equals 6. Now I'm going to add 6 to both sides. Boom, die. 6x equals 12. Divide each side by 6. X equals 2. And we're going to be left with now with a 2, comma, negative 2. All right. Now, in the rest of the unit here, that was a lot, okay? But if you understand this, you understand how to do all of these. You don't even need to do the substitution. We didn't have an example, but just so I can show you, I'm just going to make a problem up right now. Y equals 2x plus 3 and x squared plus, not x squared, sorry, 2x minus 3y equals 2. I don't even know if this problem works or not. But remember when we worked where we go, oh, let's circle that and let's put that into the y and let's substitute and solve. Remember doing all that? That was in the first thing. Well, guess what else you could do? Let's try to erase all that. Erase, erase. What is that, 2x plus 3? There we go. So instead of doing all that, here's what else I could do. I'm going to minus 2x from both sides. And if I keep them on the, so these will go away, and I'm going to be left with negative 2x plus y equals 3. And look, it's now an elimination problem just like those. So you can even take a substitution problem and just move things over, and you can get an elimination problem. So you do it however you like and how it makes sense to you, but that's how you do it. Now you get to learn how to do these in word problems, and that's always fun. Actually, I kind of find those to be fun. But if you don't, come see me on the next video, and I'll take care of you there. See ya. Bye-bye.